All right, guys, going to take a minute here to check out our solving linear equations. So when I'm looking at any type of equation here and I've got just one variable, my goal is going to be to get the terms with the variable on one side and the constants on the other. So normally I'm drawing the line just to keep it separated. Then as I'm looking at this one, I'm going to take the smaller term over here on the right, the 5x, and if I take 5x and subtract 5x from it, that's going to cancel those terms out. Now whatever I do on this side, I'm going to have to do the same thing this other side over here. So I'm taking 9x, subtracting 5x from it, and I should be left with 4x. I've also got the negative 13 over here, and right now the way it looks is equal to 57. Next thing I need to do is try and get this constant moved over here. So it's subtracting 13. I need to add 13, and that will cancel those out or zero it out. Do it on that side. I need to do the same thing over here. Plus 13, that gives me 70. So now I'm to 4x equals 70. From here, if I know 4x is equal 70, then whatever a fourth of that is what 1x will equal. So I'll divide this side by 4, divide that side by 4. So x equals 70 over 4. I could simplify that as a fraction and leave it as 35 over 2. Or if I do the division, 70 divided by 4 would be 17.5. Okay, either answer works on that one. Looking at a couple more of them. Let's see, I'll skip down to number 3. So on this one, I'm using the distributive property on both sides. So this 4 right here, I need to distribute out into the x and the negative 3. And this negative 2, I need to distribute out into these two terms. We'll do that. 4 times x gives me 4x, and 4 times negative 3 gives me negative 12. Over here, I'm doing negative 2 times 9, which would give me negative 18. And then negative 2 times negative 8x, remember a negative times a negative gives me a positive, would give me 16x. Now I can go back to doing kind of what I did on that first one, trying to get my variable terms on one side and my constants on the other. So what I'm going to do is take this 4x, that's a positive 4x. I'll subtract 4x on both sides. And then I'll go ahead and add 18 to both sides. Cancel those out. 16 minus 4 gives me 12x. And then 18 minus 12 gives me 6. So I know that 12x equals 6. I'm gonna, because my x in proper form should end up on the left, I'm gonna swap these, but at the same time, look at my division. So I'm dividing by 12 on both sides, which simplified gives me x equals 1/2. Of course, we know 1/2 could also write as 0.5. Again, either one of those works. The last one on the fraction, let's see, I'll start out adding 6 to both sides to get rid of that constant. that'll give me 20 is equal to 4/5 x. I've talked about a couple different ways you can look at it, but essentially what's happening is I'm taking and dividing this by 4/5 and dividing the 20 by 4/5 so that those cancel out. So x would be 20 divided by 4/5. The way I can think about doing this, if you're dividing by a fraction, you can flip it and multiply. So I would be multiplying the 20 times 5 and then dividing by 4. You can take and turn this into a decimal if you'd like to do it that way, or starting from the beginning, if I have 4/5 x equals 20, you might say, oh, I want to get rid of the fraction right now. So if I just multiply both sides times 5, those would cancel out. And I multiply by 5 there, which gives me 100, equals 4x. Over here, let's say I decided to do the decimal, and that was 20, and I changed that to 8/10. And I could do the division there. Either way, whether I'm doing 100 divided by 4, 20 divided by 0.8, I'm going to end up with x as equal to 25. And we'll go over some other reminders as we get a little more in depth with this, but hopefully that helps as you are looking at solving linear equations.